Hello everyone, this is Blender Guppy. Welcome to the Random Starship tutorial video. And in this video, I'm going to show you how to use the presets and also set up the redo panel properties without using any of the saved settings in the presets selection. So the presets will have its own installation video in the product page, and the product itself the product files itself contains the zip file for the um, add-on itself, and then the zip file for the presets, and then another zip file for the blend file that has a procedural shader in it. So basically a template, a blend file where you can find a shader you can use quickly. A procedural shader you can use with the add-on results to quickly test, so you can play around with renders um, very quickly. Okay, so we have the presets, angular symbols of base of top and wing sharp. So the add-on in house seed number 1 will result in different models for every use of the operator. This is to avoid the house seed value of number 1 coming up with the same model every time you use it. So I've included in a randomizer on top of the um, randomizer in the add-on to get this result. So for example, if you like the random seed number um, 16, for example, on the second use of the add-on, when you use the same value, it will give you a different model. Okay, so just be aware of that. And before we start, I'm going to show you the newly added properties to the add-on that was not included in the introduction to the redo panel properties um, before this video. So before watching this video, watch the installation video and the introduction to the redo panel properties, all these controls here, before watching this video. So I'm not gonna explain some of these properties here. So go watch that first before watching this. And okay, so the added properties in the wings, we have the wing one count property. This is the newly added one. The wing two count property is the wing count in the video, and this is what comes after the subdivision and the plating detail. So each result is affected by the plating feature and the subdivision increased resolution. And the newly added one, the wing one count, is extruded after the half section, extrusions, the bump, uh, then the wing one count property is extruded, and it is not affected by the size. Is not affected by subdivision. As you can see, I'm increasing the subdivision, and it is not changing the position of the wings. Okay. This is so you can use the wings for primary details and not just a winglet like wing two count property. Okay, so the other property is in the settings. I'm going to show you the settings. Reduce tolerance number 1. So in the settings, the newly added property is the dynamic origin. So by default, in the redo panel, redo introduction to the redo panel properties, this is the default, the dynamic origin. So you can see the original half section is in the position of the 3D cursor because this random starship is created on the position of the 3D cursor. You can see that the hull extrusion is being randomized in the y-axis direction, in the positive y-axis direction. So the origin is not really moving, only the body is moving, and thereby changing uh, the location of the origin relative to the mesh. When you toggle this off, then the back of the ship here will not move. And the origin is placed on that, reducing the hull sections. So you can use this if you want to position the ship or randomize a ship on a particular location using the 3D cursor as a placement tool. This actually looks good right here. Let me increase the subdivision. Yes, and thereby increasing the number of plating insets. So let's reduce this to 1. Okay, 2, so I can set this properly. Depths, yeah, the random depth needs to change 0.02, 0.03. There we go. So playing around um with the presets or any settings that you may have when you're playing around with the house seal value. If you're using a detailed mesh using the plating feature, if you're randomizing the result, then use a lower subdivision first. So the random sieve is actually faster. The operator is slowed down by the amount of resolution you put into the mesh, and the properties that affect the resolutions are the half section extrusions, the edge cuts, the bevel segment, the subdivision, of course, and the plating amount here. Also, let me smooth platings, and the number of wings in the wing 1 count property and also in the wing 2 count property. So they all contribute to the resolution, to increasing the resolution. So increasing the resolution, with increased resolution comes the affects the speed of the operator. So when you're playing around with the values, for example, looking for the shape that you want in the spaceship, then play around with the lower subdivision. Once you find the shape that you want, then you can increase the subdivision and also the play around with the plating detail. So for example, this one, I'm going to increase the subdivision, something like number 3. And then I can play around with the plating feature to affect the detail. So when you're playing around with the plating feature, make sure that you have sufficient rest stops on the body of the mesh, so it's not too busy looking. You can increase the size using the min max value here, and actually as explained in the last video in the redo panel properties introduction. So this is 1 means that only one face, like this one here, and 5 means this face, for example, will expand radially on a count of 5. So 1, 2, 3, 4, 5, and that forms the plate inset or plating islands. Let's reduce the reverse depth to 10% and set this size, minimum size to 2. Okay, actually, let's increase the random height to 0.5 so there's some difference in the height of the plate insets. So there's a lot of settings you can play around with here. So most of the settings that you'll really play around with is the hull seed. You can the bump. Sometimes you have to experiment with higher values or lower values. The bump limit, the bump mode. But sometimes, most of the time, I'll just leave this alone. Edge cuts, you can experiment with increased value and also bevel segments. And the plating feature here, you can you will edit thickness, depth, and height most of the time. And then yeah, this is the thickness, depth, and height are the most and then the size are the most edited properties here. The wings, most of the time I just fiddle with the count properties and change the values on the bottom part if I want to. And the settings, auto smooth I turn on, smart quantify I turn on, and with dynamic toggle you can just play around with this depending on your, if you want the origin to be random or stable at the behind the model at the thrusters. Okay, and then yeah, let's use, and also triangulation sometimes, but you can see that as I'm working, I'm not really editing them all one by one. So don't be afraid of the amount of properties here. Most of them are just exposed because they are better exposed than not. Okay, so these are the presets. The wing shape preset. We can affect the wing comes after the edge cuts as well. So increasing this value will affect its size. And also bevel segments comes up before the wing one count. So it also affects their size. And also affects the bumps as well because of the increased resolution in the on this part of the spaceship or starship. Okay, let's use a lower subdivision and basically look for the shape that they want. Actually, let's try a stubby shape or a search shape by using hull section tree. So the hull section tree is not actually, the hull section is actually 4 because of the base hull section where the rest of the hull section are extruded from. So hull section refers to the amount to the number of extrusions from the base hull section. So in reality, the number of hull sections are actually 4, and in the minimum one, the hull sections are actually uh 2. Okay, so shorter ships. Okay, this looks like this looks like a frog. Okay, so for this geometry here, disconnected geometry like that, this is the result of the symmetry. because this part here cross the symmetry line in the x-axis. That's why we have that geometry. Okay, so in reality, the mesh is actually randomized in its asymmetrical form before being mirrored. So that's why you see this. And when you flip it, you'll get the other side. Same with mirror. In the z-axis, you can flip it too, and mirror y-axis, you can flip it as well. Okay, let's randomize this. You can also use this to repurpose the add-on for other stuff like robot limbs or robot parts, um, sci-fi mechanical parts, and I've also used it for lightsaber, yeah, and also guns, sci-fi guns as well. So mirror Y and mirror Z, let's turn that off. Okay, we have this. Let's try and introduce wing count or winglets in the wing count 2, 5. Okay, to make it somewhat weirder with the pin cushion extrusions, pin extrusions. There we go. They look like antennas. So the disconnected geometry, you can randomize them out, or for example, like this one here. If you like the model and the rest of the model, but you have this type of geometry, and you're afraid to randomize the rest of the model, then you can just delete them afterwards. Press L, go to face selection mode number 3, then hover around on the face on the separate island. Press L to select them all, X, and then F, or select faces. L, X, F. Okay, and this is also disconnected geometry. L, X, F. So that's the way to get rid of them. Let's reduce swing count number 2 to just 2. Okay, this is our stubby ship. Oh, that looks good. Yep. So sometimes you will get a result that um where the front really looks like the front or the bridge, and then the back really looks like the exhaust part. So this is an emergent effect of the script or accidental. I've never programmed anything that will affect the front and the back of the ship to make them look like that. It's all purely random, but sometimes they really come out that way. I don't know, maybe it's some sort of phenomenon like I forgot what it's called. It's the way humans recognize predators like bears because of their faces. Maybe it's that kind of your mind has sampled it from your memory, and that part actually looks like the front of the ship to you. For example, like that, and then the back of the ship looks like that. So they're all accidental. Let's try 6. So actually, I'm using base scale of 1.5, so to make the ship fatter on the X scale. So you can make fat ships like that. I mean, wider ships, not fat ships. Or taller ships using the z-axis. Okay, let's just use one for all of them. Okay, the wing extrusions will only extrude from faces that are quads. Okay, so if you're aiming for 5, numbers, for example, 5 wing count extrusions, and you only see three. This means that some of the wings may have extruded in the uh, other side of the x-axis, or they may not have passed the quad threshold and is has been cancelled for extrusion. Okay, so this is the wing count is not exactly an exact number. It means that it will have 5 possible extrusions of the wing count, of the wing one count or wing two count. 5 maximum wings can extrude, but it will still have to pass the quad threshold or be extruded from a face that has 4 verts. So that's essentially a quad or 4 edges, 4 verts. Probably I'll probably just use edges. Okay, let's reduce this to 3. And if you don't like the wings, just reduce it to 0. And this is actually bumps, and they are too bumpy. So 0.2 offset and zero point 0.5. Okay, and increase the wings to 3. There's a lot of combinations here. So just look at this. It really looks like from this angle, it really looks like the bridge. Okay, let's soften it up using geometry, smoothing, or subdivision smoothing, zero point 0.2, and zero point 0.2 in the house smooth as well. We got disconnected geometry there. That is the wings. Those are the wings, so we can randomize them out. There we go. And for these hard faces here, we can play around with the auto smooth value. Let's use 30 degrees to soften them out. Not by way of geometry, but by way of normals. Okay, smart quantify 15 to 30 degrees is okay. Flip. That's good. Let's try this. This is where you use the settings to play around. Sometimes they look like guns and robot parts. So yeah, you can use it. You can certainly use them for that effect, but remember that they are mainly for spaceships or starships, random starships. So the only problem with the subdivision um, smoothing is that when you use too much, it kind of pops up the mesh. Pops up the mesh. Look at that, which is different from the hull smoothing script, which actually smooths the vertices in a natural way. But using too much will, of course, lead to this. So be careful. So this leads to fractal noise. The subdivision smoothing leads to the mesh puffing up, and eventually, using higher values, you get this look. But yeah, you can also use this if you want. Let's try increasing the plating value to 500 and use the distortion. You can certainly use it, but you have to render this far away. Oh my god. You have to render this far away. You're just aiming for the shape. But yeah, remember the excess in smoothing will lead to geometrical distortions. So um use ample amounts or just the right amounts? Okay, so yeah, let's try. This is the medium-sized ship. So this, I think we've been playing around with wing sharp. This is angular default. So these presets, they're just initial settings. You may have to play around with the settings more to get the uh, models that you want. Simple, soft base. So this is using limit smooth of base and soft tap using limit smooth tap without a smooth of 180. Same with the soft base. Yeah, auto smooth of 180 degrees. And we come to wing sharp. This is what we've been using. Okay, let's try for 16. Reduce this to 0. Let's try for 16 half sections. This is the carrier type or mothership type ship. One here. And scale interval is 4 to normalize the scale. If you're using number 1, you may find that the scaling will exponentially scale down or up. So if I use number 2 here, you can see oh my god, you can see the number 1. So yeah, like that. So it can scale exponentially if you're not using the scale interval. There we go. So we're going to use scale interval to normalize the scale. So this means that, for example, in the 16 half sections that are being extruded, in every 5 number of that half section number, there will be a scaling. The scaling will occur for every fifth number in the 16 half section count. So essentially, avoiding this phenomenon here. So that's the purpose of the scale interval. So for 16 half section, let's use 4. So for a 12, 16, and let's use 1 here, maximum. So 1 scale means that there will be no scaling going on. 1 in the scales, means that it is the original scaling or scale value, and there will be no scaling going on unless you go down or up from 1. Okay, so this means that minimum is to scale down at point 0.8, point 0.6, and then maximum means that it's going to stay on the original size. Okay, so yeah, let's use point 0.8 here, and let's randomize the shape that we want, aiming for the carrier type ship. Are we using, yeah, let's try not use mirror Z. I'm going to just, okay, there we go. Almost. It's too slender. Let's try and fatten it up. 1.2, 1.5 in the x-axis. Okay, was too slender. Okay, let's try this. So once we find actually there's no wings. Okay, let's use this with a weird and kind of weird extrusion on the front. Let's increase the subdivision, increasing the plating detail. Um, Spikes. Let's try and randomize it out. There we go. Okay, so we have our design. Next one. Okay, let's use this one. So we have our design. So you've actually committed to this, and so these are the mark sharp edges or marks or UV marked edges or marked seam, and this will only happen when you use any plating number. So after the using the operator, you can just go in, select everything, and unwrap. Okay, so the result will not be perfect every time, but there is much less work for you because most of the UV work has already been done for you, and you just have to actually break some parts. And you can also use the L hotkey for this. Go to face selection mode number 3, press number 3 hotkey, then hover around on the face and press L. And as you can see, the selection has been limited by the UV marked edges. L, and to just increase that. So you can use this to select a particular UV island and then work on this using text tools or any other UV add-ons that you have. You can also use this to isolate parts so you can model them separately. I mean, in isolation, so the other parts won't affect your concentration. So L, and it also works in UV mode. L, 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 L. And when you use this icon here, it will, of course, sync to the model, and any islands you select here will be selected in the 3D viewport. So if you're wondering, what's this part here? Press L, and then you see the part there. And then you can properly, of course, UV mark it, correctly UV mark it. Or for example, you're wondering, where is this part here? L, and Shift Z to quickly see the result. L, 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 and L. So those are the basic selection commands you can do on Blender. So working with UVs in Blender is really easy. So don't be intimidated by the UV seams, UV textures. And also after the model, if you have random flow, you can use random V color to create a vertex color for this random vertex color. So you can use it as a base color for your texturing or your procedural shaders. So we have object, which randomizes the color for every unique objects, islands for every unique separate islands inside the mesh, select for every unique selection islands in the mesh, and then we now have a new feature, which is the sharp. And this will create randomized colors for each of the plate insets that has a boundary of UV marked edges. And let's test it. I'm going to use the black and white preset that I have, sharp, and because we're using limit smooth none, and this has no mark sharp edges, Then we can toggle on use sim instead. And as you can see, it is, of course, randomizing the colors. Use sims, value, zero point 0.6, and you can see the effect of the vertex color. So each island which has a boundary of UV marked edges has a different color. Sharp, use seams, and you can also dirty the vertex color right here. Dirt only and use zero blur, and that can serve as your LUTs. That can serve as your base initial base color to multiply onto a more saturated version or layer. So okay, and if you use something like base, so this has marked sharp edges, and it also works the same. And you don't have to actually use seams for this. Also with limit smooth top, the top parts have been UV marked. The bottom part is uh the top part have been marked as sharp. The bottom part has been marked with UV seams. Sharp. There you go. So presets, wing sharp. Okay. Now we're going to set up the properties without the help of the presets. So restore operator defaults. Pulse section, let's start with 6. Triangulation is with 30. Let's use 15 degrees triangulation. Tolerance 0.1. Hull length, let's use 1. In maximum, edge cuts 0. Base scale, let's leave it alone at first. Bevel offset, bevel segments. Bump mode is phase. Bump limit is adjacent. Bump count, let's use 15. And then bump offset 0.2 minimum, 0.6 maximum. And subdivision, let's just leave it at I'm going to use plating detail, so I'm going to use 1. And then smoothing in the front and back 1. You can also use just 0.5 if you want. This is just to make the plating and bump uh, affect these areas better because of the different different elevations created by the smoothing. Okay, plating test value is 300. Size is 1 minimum. Maximum is 4 or 5. Let's try 4. Tolerance is 1 or 0.5 if you want to uh, use the default. So this just means that if the higher the resolution, the tolerance, the more that the plate insets will expand into sharp transitions like this. So for example, I use 2. You can see that this part here has, of course, um, gone part or wrapped around the sharp edges versus using 1. 1 is already making sure that some parts are being wrapped around, but if you want to really make sure, make the values higher. So for the values in the tolerance, the plating, I'll just use 1 or 2. Adjacent faces, clear or fill. Fill is more busy looking. Clear has some rest areas. So well, let's try clear for now. Thickness is the scaling of the faces on top of the inset faces. Depth is the height, and random height is also depth, but a random addition to the depth. Margin type, indent only. Margin 0.01. Okay, let's reverse it first. 20%. Okay, so indent only means that the margin will be created for faces that extrude into the mesh. This is to avoid sharp borders when two of them meet together. For example, no margin, and then you have that. If you're fine with this, then you can use zero margin, but you can just use some tiny amount just to break them apart. Okay, 20%. And the limit smooth, this will of course be useful when you use higher auto smooth values. So, but we're trying for angular look, for the angular look first, so let's just use angles of 30 degrees. But we're going to activate this and also smart quantify to quantify the mesh. If you're fine with the triangulation of the faces, you can just leave this alone. This means that this will quantify the mesh from each triangulation and leave the triangulation in some parts to keep the angular details created by the triangulation property here. Okay, so I'll just turn this off. This also has some um, minimal effects on the speed of the operator. Turning this off on higher subdivision will of course increase the speed, but just in case you're not you want those triangles, you can turn this off. Dynamic origin, it's your choice to actually just use this. If you want the origin to bounce around randomly, or just set it at the thruster area or the back area of the spaceship. Okay, so wings, wing count, let's introduce 5 here, 3. And then taper, let's bring down the value to scale it that way. Scaling it up, scaling it down. So this is the taper. And wing smooth, let's probably not use wing smooth because we're not using any smoothing on the hull section. Let's not use wing smooth. Wing rotation. So wing rotation only activates when there are uh, when you're using wing length past 1. So wing rotation of 45. Okay, I'm not getting a random wing that has a tree length. There we go. So the wing length also randomizes from 0 to the value you've entered here. 0 meaning that for that iteration there will be no extrusion of the wings. I mean the further extrusion of the wings. So using 3 means that there is a possibility that the wing can have only one increased segment, or 3 or 4. Okay, so Let's not use rotation, wing seat 1, and mirror X. You can this is turned on by default. You can flip it if you want. You can also use mirror Y for some weird symmetrical stuff on the y-axis, and then mirror Z as well. So let's just use mirror X for now. And yeah, so those are the basic operators, properties that the basic setup that you can initialize. Then uh, you can just play with the plating further, introduce some triangulation, and then play around with the, depending on the size of the spaceship, play around with the thickness and the depth, increase plating to 500, use fill, experiment with fill, or we have spikes. So we're getting really compressed areas here. So increase the scaling on that part, 0.8 or 0.6. So the scale, the hull scaling, hull length, hull scale. Yeah, I'll probably rename this to hull scale. And then you can just play around with the hull seat. Let's use 0.2 here. Oh no. 0 here, and just use 0.2 on the hull smoothing to get some hull smoothing on the some smoothing on the hull and the wings also. Let's use, where's the wings? The wings, decrease the wing taper. Okay, and the depth, margin. This is number 6, scale interval of 2, just 0.5 here. So after this, you can just play around with the length as well. Something like 10. Or use z-axis symmetry. So it's as you can see, it's really easy to set up the proper redo properties. You don't have to actually touch everything or use all of the properties. Scale it up on the x-axis 1.4. The bump, let's use none. So every face will be used for extrusion, for bumps. And let's use edge and face for the bumps. So there's a lot of shapers that you can use. Can increase the segments. Go back to face. Or increase the edge cuts in the hull section. These really a different result each time. Just remember that increasing the resolution will slow down the operator. So let's play around with shape with using no subdivision first and look for the design that we want. Okay, let's use this. Increase the subdivision to increase the detail of the plating or the effect of the plating. Let's not use any triangulation. See what we got. There we go. Nice detail with plenty of rest stops. Let's go to plating and experiment with the settings some more. Because we're done with the hull. So let's go to plating. So this is good. And then yeah, go to edit mode and UV if you want, and then repair the UV and use random vertex color here as an initial base color. Okay. For the geometry, of course, and also there's also some areas that's not gonna be perfect because this is, of course, randomized mesh. Some areas may have problems with their topology, so it's up to you to repair that if you see that, because sometimes the details can go chaotic on some areas, so watch out for that. And also for additional detail, you can use random flow or manually model the parts yourself. So for example, if you want some extrusion on this part like that, so it's up to you too. If you want wings here, additional wings, so yeah, you are provided with a really detailed mesh really quickly, and then the UV work and the additional modeling will be lighter in the after using the operator. So using the random flow add-on, random panels, if you want to use the destructive operators, which maintains the unimesh structure of the ship, unimesh being a whole mesh, and the random flow is mostly designed for non-destructive results, meaning that the result will be separate mesh. So for example, increase the count here, and where's the depth? There we go. So this is a separate element from the mesh. But with random panels and plate insets, you can use the merge function to merge the result of this. So for example, I use this part here. So initially this will be a separate element, but when I toggle on merge, then it will be merged to the source object. And this is also the same with the plate insets command. The plate insets is actually the plating feature in Random Starship. This is the same algorithm used in this operator here. And as you can see, most of the properties are actually the same. And this will generate a destructive result, meaning that it will merge to the source object and create a unimesh or a whole mesh. And if I use this plates, I'm going to use the presets that I saved. Okay, randomize the plates. What's this? Randomize the plates. Okay. We also have the indent only margin. We have the outer margin. This is the outer and inner margin is only for the plate insets operator in random flow. So right now this is working on the current resolution of the Starship model. If you want to increase the resolution of the plate inset detail using the operator, you can just increase the subdivision here. But seeing that the result is destructive, uh, means that the source mesh will also be subdivided. So their merging will not be a problem. As you can see, the difference in shading when I increase the subdivision because of the increased resolution. And also this part here, because of the increased resolution, the faces become smaller. So it merged, but it increased the resolution of the model. So you have more faces now to play with, and you don't have to actually subdivide it more. This can also work in edit mode. I just like to use it in object mode. The depth, I mean the thickness. I think it's the thickness. There we go. So in edit mode, like that, can also work like that. Work in edit mode. I mean, you can just turn off the overlay so you don't see the wireframe. Okay, so those are the tools you can use with this: the plate insets and random panels with the merge feature, and also the random vertex color. And then, of course, some of the other stuff here as well. Random cells, for example, for creating just random square details on the mesh. Let's see. Point seed, increase the depth and decrease the thickness to make it softer. Okay, so like that. The result will be non-destructive, and there is no merge feature for the random cells. So it's only possible for some of the operators in the for random panels on plate and sets, but not for the other random operators in the add-on. 50, 100, increase the island size to 2. You can increase the resolution if you want. So creates this type of detail in the surface of the. You can also bake this because it's just as lying down on the surface of the mesh. You can also just bake this detail and then get rid of it or delete it afterwards. So as you can see, this is actually a separate element, but it's when you're trying to render this will of course create its own, break up the inner spaces. Random vertex color. Now we're going to use islands. or you can use it for, let's go back to object, or you can use it for just pointy antennas, random cells, and extrude this using the depth object, decrease their number, and affect their size by increasing the um, cuts individual, and so they come out with individual lengths, reduce the thickness to 0, and making this thinner, just increase the subdivision. So you can use it for that effect, and there are others here. There are other commands in random flow as well that you can use for this for more BC for other details. So this is the random loop extrude. I'm gonna open it up using the loop inset thickness. You can also use that for detail. But use it tactically, because you can see that the detail is really busy, so use it on certain areas only. And also cables, I'm not sure if this is gonna cables. Let's use this random cables. uh I'm gonna pick this normal here, or this direction, and then random cables curve, and then limit is minimum, tangent. Okay, limit island limit is limited. So the other cables will not be created on the same island. Okay. Um, where's the offset for this? Offset for the noise. Oh yeah, the normal offset. And then we have the, oh, where's the radius? Show yourself to me, radius. There we go. And the cable amount you can set here like that. So because this add-on is designed as a utility add-on for random flow to create a Starship base mesh for random flow to work on. But of course, if you buy just the Random Starship, it can also work as a standalone plugin. Okay, but if you want more utility, buy random flow as well. Okay, so that is how you set up the, oh, that looks good. How you set up the mesh, the redo panel properties from the start without using the presets. Two, and number 3, can reduce the occurrence of the bump. Let's use number just 5, and of course, um, so the more you use the shaper properties, um, more varied the shapes will be, or the results will be. Scale interval 3, increasing edge cuts to 3, bevel segment to 5. With the bevel segments, I only mostly work at 2 or 3. And as you can see, it's quite different from using higher bump values. Let's use zero point 0.4 here and reduce the count to just 1 and this to 3. Set this to 3, set this to 1, and scale interval to 2. And we get the stubby ships again. The wings is 5 with 2 winglets, possible winglets too. The mesh is still registering. Okay, the size is probably right. Depth is 1. Hull smoothing is 0.4 or 0.3. Scale down z-axis. Let's increase the wing count. Number 2. Remember that wing 2 count property, or wing count 2 is affected by subdivision, so let's try 5 sections. That one looks good. Oh, cool. Let's play around with the wings. Let's use 2 or 3. Increase the subdivision. So there's a lot of shapes that you can come up with this because of the amount of controls that have been exposed. Okay, let's increase the subdivision. Play around with the wings. It looks cool. So right now we're using X and Z axis symmetry. That's why the mesh looks like this. Let's turn off Z axis and experiment with the shape using lower subdivision. Look at that. Three. Let's try and smooth this out. Introduce point to subdivision smoothing and one in the hull smooth, so everything becomes rounded. So right now the whole model looks different. So you're not just limited with. Let's get rid of the sharp edges, increasing the auto smooth to 90 degrees. And right now this is using limit smooth of base. Let's use top and wing counts. Okay, a wing length of 6, wing taper of 0.8, and rotation of 45 degrees. Okay, let's wing length of 8. Okay, let's play around with the settings and come out with really alien looking ships. Decrease the hull section to something like 3. Make it really stubby. Scale interval of 1. And you got this really weird shapes. Look at that. They have come. Wow. Okay, let's find a shape. Actually, this looks good. Let's increase the subdivision to just number 3. Let's go to plating and make something that's really busy. Use fill and decrease the minimum to 1. Decrease this to 3 or 4. And let's use 1000 platings. Possible plating. Okay. So nice shapes all around. Let's reduce this to 1 and look for other shapes. So okay, 0. I'm really feeling the increased resolution, like I said, affects the speed of the operator. So optimally play around with the just use subdivision 1 or 2 to play around with the shape, with the whole section shape. Oh my god, that looks like can probably animate this too. Just don't use too much plating detail, just enough so you don't have to contend with a lot of twisting chaotic geometry. So make just a simple model using the settings, and then you can animate the extended wings, make them make them fly like the some of the exotic jellyfish in the sea with their tentacles. Okay, this looks good. Actually, let's try and 10. And this is 5. And let's see what we get. Holy. And let's use base. Oh my god. This looks really cool. Let's increase this to 12 and see. Okay. These are the carrier ships of the really weird alien civilization. They are carrier types. Holy cow. So as you can see from our angular, soft top, soft base, and simple, and then we have the angular. So different results for each different setting. So you can come up with really weird shapes using this add-on. So from this to this, look at that organic form. All it needs now is some shader and then some lights and then some exotic lighting, and this can look like a living ship versus this one. This one is made for battle, destroying worlds. Well, this one is more exotic, more more for life, but weird in a way. Okay, so I'm gonna stop this video right here because I'm really enjoying myself because of the amount of shapes you can come up with this. Okay, so yeah, there you go with the presets and how to set up the redo panel properties from the start without using any of the presets. Okay, so remember the product file has the zip file for the add-on. There's a different installation for that. A zip file for the presets, different installation on that. All their links will be in the product page. And then another zip file for the blend template that includes the procedural shader you can use to quickly texture your spaceship until you create your own. Until the time that you have created your own for this add-on. Okay, so thank you for watching. If you have any question, use the comment sections below or the links in the description. And have a nice day.